Hey guys, today's question is count ways to build good strings. In this question, we are given with four integers 0, 1, low, and high, and we have to construct some good strings. Okay, and in one operation, what we can do is we can append the character 0 number of times, and this 0 is an integer, it is not value 0, and we can append the character 1 number of times. Okay, now a good string is defined as a string that has a length between low and high. Okay, the string has length between low and high, and it is formed by using only these operations. Only these two operations is called a good string. We have to return the number of different good string that we can form by using these operations. Okay. So what will be our approach is, what we can see at every step we have two choices. We can insert 0 number of times, and we can insert character 1 number of times. Okay. As we have two number of choices at every step, so the answer will be exponential if we do a brute force approach like vectoring, etc. So what we will do is we will go for a DP approach. Okay, as every time when we have some options, we always look for the DP approach. Okay, so we will look for DP approach, and what we will do is we will simply first we will insert 0, and next we will insert 1, and finally if the current length is is between low and high, we will return 1 plus the we will call the function for higher values also, because the high is not reached. Okay, and when the length is greater than high, then we will return simply 0. Okay, that will be our base case. Now let's try to code this. Also we have to take mod, because the answer can be so long. So constant int mod equals to 189 plus 7 is given in question, 10 to the power 9 plus 7. And also, as we have to take the long, so let's define ll. So hash define ll as long. Okay, now we will simply call a function return solve. We will pass the current index, which will be 0 initially, low, high, 0, and 1, all the variables. Now let's create this solve function. Okay, so it is a long type function. So ll solve, the first value is the index int I, then let's take these four variables by reference, because these will not change. So int and low, int and high, int and 0, the last one is 1. Okay, now the first base case, if the current index is greater than high, then we can't then the limit is reached, so we can't perform any operations. We will simply return 0 at this point. Okay, so return 0. Now second, so we will memorize here. Second, if I is greater than equals to low, that we are, and this condition is not satisfied because this condition is written above it. So that means at this point the current length is between low and high, then we have to return 1 plus the next operations. Okay, so we will return 1 plus, let's take all this in bracket because you have to take modulus mod. So 1 plus, we will solve for the next values. So let's simply copy. Now if we are uh, inserting 0, so the next value will be, next index will be I plus 0, because we will insert 0 number of times. Okay, let's take mod here, plus, if we are inserting, wait a second, if we are inserting ones, then the next index will be I plus 1. Okay, because there are one number of ones. Now we have to take mod of this also, so I modulus this modulus mod, and the whole will also be modulus by mod. Okay, this is the case. And if the I is less than low, okay, in that case, the else case, we will simply return, we will not insert 1 only. so we'll return this value. So let's copy all this. We will not add 1 because this is not the correct index between low and high. So that's it. Okay, now let's see if this is working now. So compilation error has defined. So okay, extra semicolon was there. Okay, the code is accepted. So now, as it is a DB code, let's memorize it. So let's take a DB array. The constraints, let's see the constraints. 10 to the power 5. Okay, high can be 10 to the power 5. So 1, 2, 3, 4, 1. 10 to the power 5 plus 1. And now let's use the mem set. Let's take all values in -1 initially. Size of DP. Now at every step we will simply check if the current index we have already evaluated or not. So if DP of I not equals to -1, that means we have already evaluated that value. We will simply return we have already calculated value dpi, and else we will returning those values, will simply memorize it. Return dpi equals to this. Also here return dpi equals to this. Okay, now let's run this. Okay, let's try to submit, and if it gets submit, let's move to the bottom up code. Okay, so the recursive approach is submitted. Now let's move to the bottom up approach. Okay, let's remove all these this solve function and this value also. Okay, now for bottom approach we first need a vector integer dp. The range will be high plus 1. Okay, and initially all values will be 0, but the first value will be 1. Okay, dp of 0 will be 1 because a empty string is also valid. Okay, now we will iterate over this array. What we will do, what we will approach is, at every point we will check if we can insert the, if that string can end with 1 at every length, if that string can end it with 1 or it can end with 0. Okay, these two cases. If it can end with 1 or it can end with 0, we will check if -0 times or -1 times if this value is in the range. That means that that value can end with that value. Okay, so that value can end with 0 or 1. Okay, and we will simply add both of them. So we will simply iterate over this array. So for in I equals to 1 less than equals to high and I plus plus. Simply if the I minus 0 is in the range, that means we can insert number of zeros. Okay, so greater than equals to 0 if this value is, then dp of I will be dp of I plus dp of I minus 0, number of strings that can be made at that point, and simply take modulus at every point. Okay, also if I minus 1 is in the range, if it is greater than equals to 0, then okay, let's remove the semicolon. dp of I equals to dp of I plus dp of I minus 1, number of strings that ended at that point, and simply modulus mod. Okay, finally after this execution we also have to count the number of strings that are in the range low and high. So we will use another for loop for that. Before that, let's take the variable 0, sum as 0, and now to calculate the sum, so for int I equals to low, I less than equals to high, I plus plus, simply sum equals to sum plus current value, which is dp of I and modulus mod. Okay, after this for loop we can simply return the sum. Okay, try to run this. Okay, so let's submit this. So the code is accepted. Thank you for watching.